our meeting here. And pull up our notes for today. All right, there we go. All right, sweet. So for today, for the most part, everybody did a really good job with that Monday question about the physical changes versus the chemical changes. Most people got down pretty well that it was physical changing is all about changing the form or how something looks. And a chemical change is actually changing the substance, changing the identity of the substance that you're working with. So really good job, all you guys, on that question. Today, we're going to be looking even deeper into kind of talking about those little tiny particles that make up everything else in the universe. All of the matter that we have been talking about so far, whether it's a solid or a gas, whether it's flammable or it's shiny or it's see-through, it's all made up of the same general type of particle. And those particles have a name, and they are called atoms. So today we are going to be talking about atoms. We're going to be talking about the structure of atoms, or kind of how atoms are built. And we're going to be relating that back to a big chart that shows all of the atoms called the periodic table. So we'll be talking about all of this stuff through our notes today. So here is the periodic table. You've probably seen it before if you've ever taken a high school science class of any kind. It's probably been up on one of the walls in the room. It's this big chart made up of all these little boxes, and every single one of these boxes is a different atom. There's some that you might be familiar with. So there's helium, like what goes into party balloons. There's carbon, the stuff that we and animals and plants are made out of. There's oxygen, like the stuff we breathe. There's things like aluminum and zinc, and this guy right here is gold, and silver is up here. And then a whole bunch of ones that you've probably never heard of before, like lithium or rubidium or cesium. Cobalt, oh, here's iron. You probably heard of iron. But then things like uridium and plutonium and all sorts of fun stuff like that. All of those different types of atoms are on our periodic table right here. And so today we're going to be talking about what are the parts of an atom. So what makes these atoms what they are, and how are they different from each other. So we're going to talk about each one of these charts has some numbers that are associated with it. And we're going to talk about what those numbers mean and how we can use those numbers to figure out different important things with our atoms. So here is kind of a simple cartoon drawing of an atom. An atom is the scientific name for those tiny particles that we've been talking about with all of our different substances so far. So like when we were talking about solids, liquids, and gases, I mentioned that there's these tiny particles that in solids, they're kind of vibrating, and in liquids, they're kind of moving around each other, and in gases, they're moving really far apart really fast. Those particles are called atoms, and they are the smallest unit of matter. They're the smallest little individual building blocks that matter is made up of. So everything in the universe is built out of a different combination of atoms. So there are three major particles that make up an atom. There are protons, neutrons, and electrons. And today we're going to be talking about what these particles are, where you can find them in the atom, and how you can figure out how many of them an atom has, because each atom has a different number of protons, neutrons, and electrons, And luckily, as long as you have some key information, it's really easy to figure out how many each atom has. So we can split our atom into kind of two general regions. We have the nucleus here at the center, and then outside of the nucleus, kind of all around. So the nucleus is the sort of middle part of the atom, the center area of the atom. It's basically where all of the weight of the atom comes from. All the little stuff on the outside doesn't really add to the weight of the atom. It's all based in our nucleus here. And there are two types of particle that we can find in the nucleus. There are protons and there are neutrons. So protons and neutrons can be found in the nucleus. But what are protons and neutrons? What makes them different from each other? So protons, in this picture, they're shown as little red balls in here. Obviously, in real life, they're not red. They don't really have a color. But in order to distinguish them, they're the little red balls here. Protons are hanging out here in the nucleus. And the important thing to remember about protons is that they are positively charged. So if we wanted to represent the charge on a proton, we could use like a little plus sign. So easy to remember, protons are positive. P for proton, P for positive. So they're hanging out here in the middle of the atom inside the nucleus. So we've got our positive, protons, and the nucleus. The other thing that we have in our nucleus are our neutrons. So the neutrons are hanging out here in the middle of the atom, the nucleus as well. They're in blue in this particular picture. Neutrons do not have a charge. They have, you could call it like a neutral charge, or sometimes you'll see it written as a zero charge. So they're not positive, they're not negative, they're neutral, right in the middle. They're at the zero charge mark. So the neutrons and the protons are hanging out here in the middle of the atom in the nucleus. And the cool thing about the neutrons and the protons is that together, the neutrons and protons make up like 99.999% of the mass or the weight of the atom. So if you take your number of protons and your number of neutrons and add them together, it basically gives you the weight of the atom, also known as the atomic mass. That's going to be important for something we talk about in a little bit. So just kind of store that in your memory banks right now. So in our nucleus, our middle area of our atom, we've got our positive protons, we've got our neutral neutrons, and when we put protons and neutrons together, we get the atomic mass, the overall total weight of the atom. So that's all well and good for these guys, these protons and neutrons clumped together in the nucleus in this middle area right here. What about stuff on the outside? What's going on with these little green guys out here? So those guys are not protons, they're not neutrons. They are called electrons. So electrons are not in the nucleus. They kind of orbit around it. So just like the moon orbits around the Earth, the electrons orbit around the nucleus. They're kind of over here spinning all around. Electrons have a negative charge. So these are our negative particles in our atom. You got the protons that are positive, you've got the electrons that are negative, and then you've got the neutrons that are neutral. The thing that people do sometimes is that they hear They got protons positive. That's pretty easy to remember. But then they hear neutrons, and they think that means neutrons means negative. No, that's wrong. Don't think that. Neutrons are neutral. They don't have a charge. They have like 0 charge. Electrons are our negative particle. The way that I personally kind of always remember it is that electrons are what electricity is based on. So electrons flowing around is what gives us electricity. And if you get hit with electricity, you're going to have a negative time. You're going to have a bad time if you get an electric shock. So that's the way that I remember that electrons are negative, because electricity will negatively impact your life if you let it touch you. So they're outside of the nucleus. There are little negative particles that are zooming around out here. And electrons, even compared to the protons and neutrons, are super duper duper incredibly tiny and light. So they don't really get counted for the mass, for the total weight of the atom. They're there and they're important. They have these negative charges that balance out with the positives from the protons, but they're so tiny that they don't really get added on to the mass of the atom. We pretty much just count up the protons and the neutrons to give us our atomic mass, our weight of the atom. All right, so we've got our 3 different particles: protons, neutrons, and electrons. Our protons and our neutrons are together in the middle area, the nucleus right here. Protons are positive, neutrons are neutral, and then we've got our electrons, which are outside of the nucleus going around, and electrons have a negative charge, negatively charged electrons. Electrons are super small and tiny, so only the protons and neutrons really get counted together to give us the atomic mass. So all atoms are made out of a combination of protons, neutrons, and electrons. From the super tiniest guys, like hydrogen and helium, to the biggest, heaviest atoms, like uranium and plutonium. They all might have different amounts and different numbers, but they all have some sort of combination of protons and neutrons and electrons that make them up. The different atoms are really only differentiated by how many protons, neutrons, and electrons they have. All right. Does anybody have any atom questions, any proton, neutron, electron questions so far?
You said earlier they don't have color, but can you still see them, like under a microscope or something?
Not, honestly, these guys are so small and so tiny that even under the most powerful microscopes that we have, like the super duper ultra electron scanning microscopes, we can barely sort of see even some of the biggest atoms. So these atoms are incredibly tiny. Like if you think about, like if I make like a little dot that's like the size of a period on my paper here. Let me see if y'all can see it. So this little dot that I made on my paper here, atoms are so small that you could fit about 1 million atoms from one side of the dot to the other. And that's just if you put them all in a straight line across from each other. So we know they're there. We can study them in different ways. But even with the most powerful microscopes, we still really struggle seeing individual atoms. Good question. Anybody else? Any other atom questions or proton, neutron, electron questions? All righty. So like I said earlier, all atoms are represented on that big chart called the periodic table. And the one that we were looking at on the slide here was kind of a squished down condensed version, so it didn't have as much information on it. But most full-sized periodic tables, they have an individual little box for every single atom that scientists have discovered so far. And in that box are usually 4 pieces of information, 2 words and 2 numbers. So the 2 words usually indicate the name and the symbol for the atom. So for example, here we have the periodic table box referring to the atom krypton. So we have the name of the atom, krypton, written out right here. And then a lot of times when scientists refer to different atoms, or we make diagrams that have the structures of atoms, we don't want to write the name out over and over and over again. So each atom on the periodic table has a 1 or 2 letter symbol that represents it, right? So helium is represented by He. Carbon is represented by C. Oxygen is O. Nitrogen is N. Iron is Fe. Zinc is Zn. Krypton is Kr. So whenever we're writing like the atomic formula of something, and we write Kr, scientists know that that is referring to the atom krypton. So we have our name and our symbol. Those are the 2 kind of word-based pieces of information that we have. The other 2 numbers are called the atomic number. It's going to be the smaller of the numbers, usually located at like the top corner or the top middle of our periodic table box. And we also have the atomic mass number or the atomic weight number down here, usually located on the bottom, but it's always going to be the bigger number. So the atomic number is smaller, the mass number is bigger. The atomic number is usually located at the top, like in the middle or in one of the corners. And the mass number is usually on the bottom, again, in the middle, or sometimes in some of the corners. In each of these pieces of information, each of these numbers can tell us something about the makeup of our atom. So that atomic number up at the top, that number tells us how many protons are in our atom, how many protons are in the nucleus. Every single atom has a different atomic number, from number 1, which is hydrogen, to number 6 is carbon, number 36 is krypton, and I think the highest one that we've discovered so far is like 118 or 119, somewhere up there. No worries, Shannon. Good to see you. Thanks for being here. So every single atom has a different atomic number. And the atomic number of each atom tells us how many protons are in the nucleus. That's basically the way that scientists use to determine which atom is which. They divide them up by the number of protons. If you have a different number of protons, then you have a different atom. So krypton, right here, has an atomic number of 36. So krypton has 36 protons. Carbon has an atomic number of 6, so it has 6 protons. Lithium has an atomic number of 3, so it has 3 protons. Whatever this number is, whatever the atomic number of our atom is, that is how many protons it has. So protons are super simple to figure out for an atom. You just look at the atomic number. So protons, atomic number, same thing. This one's pretty straightforward. The next one is slightly more tricky. So our atomic mass, also sometimes called the atomic weight down here, essentially tells us how heavy that an atom is. So since atoms are so small, like Ruben B mentioned earlier, you have to use a super duper crazy powerful scientific microscope, and even then you can't really see them because they're so tiny. We can't be using things like grams or pounds or ounces to measure the weight of atoms, right? Because each atom, if you wanted to write out its weight, it would be something like 0.000000000000000000000000000000083 pounds. And nobody wants to deal with all those zeros when they were trying to figure out how much atoms weighed. So instead, they came up with this new unit called an atomic mass unit. And they basically said, okay, a proton is basically 1 AMU, and a neutron is the same size, so it also is basically 1 AMU. So our atomic weight down here is how much an atom weighs in these atomic mass units. So it's a good way to compare single atoms of each element to each other. So the bigger this number is, the heavier that the atom is, and the more protons and neutrons that it has. So this number here, it just tells us the weight of the atom. So the atomic number was nice because it directly told us the number and the number of protons. The mass number here just tells us the weight of this atom. How much does this atom weigh in AMUs, atomic mass units? So that's great and all. That is good information to have. But we want to know specifics about things like protons and neutrons and electrons. So the nice thing is that we can do a very, very simple calculation in order to figure out how many neutrons that an atom has. And the calculation goes a little like this. I mentioned earlier when we were talking about protons and neutrons that if you take our protons and you take our neutrons and you add them together, they'll give you the atomic weight. So the atomic weight is mostly made up of how many protons and how many neutrons are in your atom. If we take those numbers and add them together, we can figure out the atomic weight. And so if our protons are the same thing as our atomic number, and the protons and neutrons together tell us the atomic weight, so if we take that atomic weight and we take away the number of protons that we have, which is the same thing as our atomic number, we can figure out our number of neutrons, right? If our protons and neutrons together are our atomic weight, and you take away the number of protons, then you're left with the number of neutrons. So if you do the atomic weight, that bigger number on the bottom, minus the atomic number, that smaller number at the top, it will tell you how many neutrons that you have. So if we look at our krypton example right here, krypton has an atomic weight of 83.8. Now, obviously, we can't have a point some number of neutrons, and a lot of times you'll see these decimal places when you're dealing with atomic weights. That's because scientists using fancy machines are able to take super, super precise weights and calculations of these atoms. we don't really need to be that precise in this class. So you can round the atomic weight to whatever the nearest whole number is. In this case, 83.8 is basically the same as 84. So we'll say krypton has an atomic weight of about 84. So if our atomic weight is 84 and our atomic number is 36, that means we have 36 protons. And if we want to figure out our neutrons, we can do our atomic weight of about 84, subtract our atomic number of 36, and this tells us that krypton has 48 neutrons. All right. So we did the atomic weight, which is the protons and neutrons together. We took away the atomic number, which is just the protons. And if we take the protons and neutrons together and take away the protons, we are left with the neutrons. So krypton has a weight of 84 and 36 protons. So 84 minus 36 is 48. In order to figure out the number of neutrons an atom has, you can take the rounded atomic weight number, subtract the atomic number, and it will tell you how many neutrons. So the most common thing that people sometimes get confused about is they either think that the atomic weight is the number of protons, just like the number is for neutrons, just like this is for protons. Don't do that. Remember, neutrons, you always have to do a calculation. And sometimes people get confused and they try to add the atomic number and the atomic weight, or they do like division or multiplication or something. You just need to do very basic subtraction. Atomic weight minus atomic number gives you the number of neutrons. 84 minus 36 is 48. There are 36 protons and 48 neutrons in one atom of krypton. All right, any questions about figuring out proton or neutron numbers so far? Anything about those steps that you want me to go back again or are still a little confused about?
So are we rounding the atomic weight?
Mm-hmm.
Okay.
Yeah, so just to make it so that you don't have to deal with these confusing decimal points, yeah, it's always okay to round the atomic weight to the nearest whole number. So on this one, or some of them are even more obvious, like there's some that's like 18.999 can obviously be rounded to 19. Like 20.889 could be rounded to 21. And then there are others that's like 12.002 or 14.070. Those could obviously be rounded down to 12 or 14. So yeah, whatever the nearest whole number is, go ahead and round your atomic weight to that number. Like I said earlier, the reason why on official periodic tables you'll see them with like a bunch of decimal places is because of scientists taking like super precise calculations and measurements that factor in a whole bunch of stuff about the atom. We're just going to worry about the rounded atomic weight number. All right, good question. You are going to be doing some of this for your homework today and tomorrow, in which case it's definitely easiest to just round that atomic weight number.
Excuse me.
Mm-hmm.
Anyway, equal neutrons. Anyway, about mass plus number.
So the mass plus the number doesn't really equal anything. That doesn't mean anything about
Neutrons.
it. Just is minus. Subtract. So the weight minus the number is the best way to figure out how many neutrons that you have. I think that's what you're asking, if that helped at all.
Yes, thank you.
No problem. All right, so atomic number is how many protons that we have, and the weight minus the number is how many neutrons that we have. So that's protons, that's neutrons, but I feel like we're missing out on something. So, the electrons. We also want to know, how many electrons do our atoms have? Luckily, electrons are very, very easy. The type of atoms that we're going to be dealing with in this class are called neutral atoms, meaning that they are balanced. And what we mean by that is that they have an equal number of protons and electrons. So like I was saying earlier, protons are positively charged particles and electrons are negatively charged particle. So in a neutral atom, there'll always be the same number of positive charges and negative charges. They'll always be the same so that we don't have more positive and we don't have more negative. It's always equal, so that it's always a neutral charge. The positives and the negatives cancel out, and that gives us no charge on our atom. So neutral atoms always have the same number of protons and electrons. So we're just saying that protons are really easy to figure out. It's just the atomic number. Electrons are also really easy to figure out because they have the same amount as protons. So electrons and protons will always be balanced in the atoms that we worry about for this class. There are cases where you can have more electrons or fewer electrons, which would give your atom a negative or a positive charge. We're not going to worry about that in this class. We're just going to focus on neutral atoms, and neutral atoms always have an equal number of protons and number of electrons. So the proton and the electron number should be the same. So like hydrogen right here, hydrogen is the simplest atom in the universe. It consists of one proton in the nucleus. And because hydrogen has one proton, it has to have one electron circling around. 1 and 1, same number of protons and electrons. So your proton number and your electron number should always be the same. They have to be balanced with each other in order for those positive proton charges to be canceled out by those negative electron charges. So that's sort of a super duper basic example. But let's look at a little bit different example, and I'm going to have you guys help me out. Here we have the periodic table box for the element carbon. Super important element. It's what almost all living things on Earth are built out of carbon, including you and me. So carbon, it's called carbon. It has a symbol of C. Carbon has an atomic number of 6 and an atomic weight of 12.01. So, first question that I want to ask you guys, how many electrons does carbon have? We were just talking about electrons. How many electrons are in one atom of carbon?
6.
6. And Mr. Bueno, how did you know that carbon had 6 electrons?
The atomic number.
Precisely. Carbon has an atomic number of 6, which means that carbon has 6 protons. And like I was just saying, if carbon has 6 protons, that means it also has to have 6 electrons. So it's a neutral atom. It's balanced with its proton and electron numbers. And so if there's 6 protons, there has to be 6 electrons. All right, very good. Let me also ask you guys to get a little bit more practice in with this. If carbon has an atomic number of 6, which means it has 6 protons and 6 electrons, how many neutrons does carbon have? Ooh, Alexia says 6. Alexia, how did you know that carbon has 6 neutrons?
I subtracted the atomic mass from the number of protons.
Exactly. So our atomic mass or atomic weight of carbon is 12.01, which is basically 12. We can round that to 12. And the atomic number of protons is 6, and 12 minus 6 is 6. So carbon is a cool element because it has the same number of protons, neutrons, and electrons. You'll see this happen a lot for smaller elements. So like the first, 7 or 8 elements have the same number for all of those. But then as you get bigger and bigger, you get a bigger difference between the neutrons and the protons and electrons. But yes, excellent job. Carbon has 6 protons because it has an atomic number of 6. Carbon has 6 electrons because the protons and the electrons have to be the same, and there's 6 protons. And carbon has 6 neutrons because 12 minus 6 is 6. All right, I'm going to rewind here a little bit to do one more example of this with you guys. So krypton, we already talked about, has 36 protons and 48 neutrons. So how many electrons does krypton have? Feel free to answer either out loud or in the chat, but how many electrons are in one atom of krypton?
36.
36, exactly. And Annabelle, how did you know that there are 36 electrons in krypton?
The proton.
Exactly. The protons and the electrons have to be the same, and there's 36 protons in krypton. That's what this tells us right here, which means there also have to be 36 electrons in krypton as well. I see Alexia and Rosita got it right as well. Very, very good. All right. So the reason why I was going through actually, hold on. Let me hold on for a second. So hopefully those couple of examples helped you guys kind of understand how we figure out these 3 important numbers that relate to our atoms. Does anybody have any questions, anything about the proton, neutron, or electron numbers that you want a little bit more clarification on, or you still are a little confused about? All right, does everybody feel pretty okay with if I gave you a periodic table box like this one? You'd be able to tell me how many protons, neutrons, and electrons that it has. All right, well, I definitely hope so, and hopefully those examples helped you out some, because your assignment for today, the daily assignment that was posted for Tuesday today, is going to have you do that a couple different times. So the atomic structure practice that was posted for today has 6 different atoms listed on it. There is fluorine that has an atomic number of 9 and an atomic weight of about 19. There's scandium, has an atomic number of 21 and an atomic weight of about 45. There's platinum, has an atomic number of 78 and an atomic weight of about 195. There's radon, which has an atomic number of atomic number of 86 and atomic mass of about 222. There's uranium, which has an atomic number of 92 and an atomic mass of about 238. And then finally, borium, which is so big that scientists can only estimate its atomic mass so far, which is why it has it in this little bracket right here. But borium has an atomic number of 107 and an atomic mass of 264. And so for each one of these atoms, I want you to go through and tell me how many protons, how many neutrons, and how many electrons are in each one of these atoms. So if you do this on the Google form version, it means that you have to make sure that each one of the answers that you put in has three pieces of information. So obviously this is not going to be correct, but you'd want to say something like not one rotin, that's not a thing. 1 proton, 2 neutrons. Man, I cannot spell. 1 electron. 2 protons. How do you spell that word? If you want to, you could write it out like that. It's also fine with me if you just shorten it to like 1 proton, 2 neutrons, 1 electron. I can figure out what P, N, and E mean in this context. Make sure that you at least label them with some sort of P or proton or pro or whatever it is, just so that I know which number refers to what. But so you should have that same kind of setup for your answers for each one of these 6 atoms. So tell me how many protons, neutrons, and electrons that it has. If you want to do the Google Doc version, that's fine too. It actually, for once, this one's set up a little bit easier because I was able to list out specific spaces for the, there's the pictures popping in, for the protons, neutrons, and electrons. So you can just come in and write like 1, 2, 1, and there, if that works easier for you. Again, whichever one works better for you is fine by me. Just make sure if you do the Google form version that you write in all 3 particles for each one of your answers. So each atom should have the protons, the neutrons, and the electrons listed out in the one little answer box down there. So that is for today's homework. And then tomorrow's assignment that'll get posted early tomorrow morning for Wednesday is super simple. It's a very super basic overview of all the stuff that we went over today. So it has a little write-up about protons, neutrons, electrons, how the periodic table boxes work. And then it has this box for this particular atom right here. And I just want you to tell me the very basic information about the atom. What is its name? What is its symbol? What's the atomic number? What is the mass number? You can round it, or you can leave it as it's originally written. Whichever one you do is fine by me. The one thing that people always forget on this one, make sure to read the question carefully, because this is a little bit of a test of reading and answering all the parts of the question. Number 5 down here, I want you to tell me how many protons and how many electrons are in helium. So this one, number 5, should have 2 answers on it, the number of protons and the number of electrons. Even if it's the same number, I want you to write it in there twice. And then finally, how many neutrons are in helium? This one, you only need the one number for the neutrons based on the mass and the proton number from earlier. So super simple overview, just to kind of keep all of that atomic information fresh in your mind when we get to Thursday. All right, does anybody have any final questions about anything from the notes of today, the protons, neutrons, and electrons, and how to find their numbers, or anything about the homework assignment for today and tomorrow?
No.
All right, awesome. So one final thing that I wanted to mention before we wrap up for today is that something that me and some other teachers have noticed is that we tend to get a little bit of attendance dips on those asynchronous days when you guys aren't coming on to class like you are here. So for us, that would be Mondays, Wednesdays, and especially Fridays. We've noticed a lot of people forgetting to log on and do their daily assignment on Fridays. Luckily, based on the names that are in here, it looks like most of you guys have already been doing a really good job of keeping up with all that stuff. But just a reminder, please be making sure to log on to the Google Classroom on the days when you don't have IPC class, especially including Fridays, doing the daily assignment that's posted up there so that you can make sure to get your attendance credit for that day. We want to make sure that everybody in all the classes across the Excel Center has no issues with attendance going into the last term of the school year here, so that you can finish up and get your IPC science credit by the end of the term. So keep up the good work already. For most of y'all, I know you've already been doing a great job about this, but always remember to check in on that Google Classroom at least once a day, especially on Fridays, so that you can be turning in those daily assignments and getting counted for attendance. Just wanted to bring it up because it's something that some of the other teachers and I have noticed, is that our Friday attendance has been taking a little bit of a dip across, not just for this class, I promise, it's across the entire school, we've noticed it.